Okay, good afternoon, everybody. So we are starting the second session in second day. I request Balwan Gorad sir, please start the session.
Thank you, sir. Good afternoon and welcome back. I am Vaibhav Narawade, Assistant Professor at Ramrao Adik Institute of Technology. On the behalf of Department of Computer Engineering, RIT DY Patil deemed to be University, I welcome all our participants and viewers who have joined us through YouTube Live for second day, second session on Faculty Development Program in Recent Trends in Internet of Things, sponsored by AICT Atal. Internet of Things is not only about connecting billions of devices to the internet, but also about connecting people, services, applications, businesses, infrastructures, among many others. What makes IoT even more interesting is how data and technology can be blended to build sustainable IoT data analytics applications. With billions of devices, in embedded in environment or products, continuously generating huge amount of data, which can be a real-time data in many different formats, which builds sustainable Internet of Things data analytics applications is becoming more challenging. While it is envisioned that IoT applications would typically perform data processing on the cloud, a growing number of limitations in meeting applications demanding prompting researchers to investigate more efficient ways for pre-processing the data. This talk will provide insights into ideas and approaches towards IoT data analytics applications and smart systems. For today's sessions, this session will be on smart systems and IoT analytics by Dr. Amiya Kumar Tripathy sir. He is professor in computer engineering and director of Center for Data Analytics at Don Bosco Institute of Technology, Mumbai. Dr. Tripathi sir is also working as adjunct professor to School of Science, Adik University, Perth, Australia. He had been a research mentor to Smart Farming Project, Thailand, with RM Institute of Technology, Bangkok, Thailand. Earlier, he was in the role of secretary to RUSA, that belongs to Government of Maharashtra, for higher studies in geospatial technology. Dr. Tripathi sir has earned his PhD from IIT Bombay and has been 24 years in software industry, research and academics, having 125 plus publications in reputed journals and conferences. He also has been an editorial board member to IEEE transactions on computational social systems and Elsewhere's Journal of Information Science. He has been the general chair and program chair to many IEEE and ACM international conferences. He has delivered many talks across the India. His research interest includes machine learning, data science, sensor networks, ICT for agriculture, and rural development. We are glad to have you with us, sir. I welcome and invite Dr. Amiya Kumar Tripathy, sir, to start the session. Over to you, sir.
Amiya sir, please check your audio system.
Share my experience working in different IoT sectors in Australia, Thailand, and India. So the today's talk is going to be some of the experience, including some industry work also involved in these cases. We'll have some sorts of things inside it. Now let me go through it. When we talk about a sensor, or you talk about a smart sensor, that comes in the mind that it should be some package, some instrument which may have a microprocessor, may have a microcontroller, and which can drive or can be driven by different other devices towards communication, including a onboard diagnostic also, and that is towards monitoring a particular system which is with a better efficiency and maintenance cost also. So the aim is to integrate electronic parts or electronic sensors and with a little bit of intelligence into it, and that becomes a so-called a smart sensor we talk about. Now we have been looking into or seeing many aspects of so-called the IoT and analytics and merging these into so-called the IoT analytics. The word data and the data analytics have taken definitely the business world in a storm. Of course, now we are talking about improving any business or any productivity, and its performance definitely depend upon the how we are taking and analyzing data in a real-time mode. Real-time mode means what we talk about is a data in motion. Earlier, what we have been seen, data collected and data we have analyzed, that is called the data at static. Now we want that one data should be moving, and at the same time that the analytics has to be carried out. So this requires a new generation technological advances. And of course, when comes a data collection, and of course the IoT is playing a greater role to serve different purposes of society and industry and business world also there. So the data collected through different IoT devices having different techniques are now compared and has been taken into account traditionally to conventionally to a modern technology. So when we talk about the analytics of IoT data, you require a sophisticated skills for analysis of such kind of things are there. When we look for different application in 2020, right? So this graph is trying to say that when the manufacturing or industrial unit is the mode which IoT has been used, followed by the transport and mobility, followed by energy, retail, and all such kind of things. Once the Satya Nadella of CEO of Microsoft has told, industrial IoT is transforming the rules of manufacturing, fueling, cloud, and edge innovation, and which is accelerating and the evolution of digital factories, which is towards a operational performance. That is what the Satya Nadella has told in 2020. So when we talk about the analytics of IoT, right, of course, it starts with a hype. Now, what this hype is trying to say is that the IoT definitely has caused a lot of hype across the business industries. It is also a rapidly advancing field, so keeping up the latest trends is a must for many business. The roots of IoT are spreading far and wide, so it is quite easy to come across the term, but it is not just another complex technology that business are using outsmart each other. If utilized in the right way, it can produce a unparalleled intelligence for any kind of business. And as usual, it depends upon how the business process the excessive inflow of data from IoT software or hardware is to be taken into account. So when you look for a traditional data or a IoT generated data, this is something comes in picture. A business has a simple or a multiple source of generating data, but IoT changes the value of the data. In comparison to the traditional collected data, one generated data through IoT is a real time. So this is immensely useful for the industry that can flourish given a constant stream of freshly generated data. So when we talk about the traditional data or the IoT data or its relevance, so the traditional data has been supported business on a static data, as I just told you. It will be wrong to undermine the importance. However, the business world has become highly competitive and it is only going to be intensified in those terms. So for this purpose, now where a smarter technology are needed, therefore, business are now finding it necessary to invest in the IoT. So it is not an easy process for such as complex information. There are many sensors sources within a IoT network. So it becomes important to differentiate between the multiple sensors point and external components, and that may be responsible for reading the data points. Also, more technology layers are added or integrated with IoT. It becomes more difficult to structure and process the multitude of incoming data. So yes, it requires a different kind of skills to take off or to comprehend the IoT generated data. Next question comes to that: how it is changing the face of data. As popularity of IoT increases, a surge of data lies in the future. So it is bound to change the way we are having viewed data for some time now. The boom in the data is not only going to require better infrastructure, but a smarter data or data analytics. We will need an infrastructure that can reliably process a constant stream of complex data, and it will be serious waste of time and money if we can't use the source of data to make more or better sense out of it. So therefore, this explosion of data should be an opportunity for any kind of data analytics. So by taking advantage of this for IoT, so not only it is helping the business industries in terms of better performance and profit, in fact, we can create a better world with a smarter analytics. We can resolve multiple problems globally. And obviously, there is a second on IoT data for changing the world. So this is helping to overcome some global challenges. It can help generate more accurate decisions also there. This means that processing of data will become easier as device will be able to self-learn because of the intelligence in nature and identify different pattern also. So the opportunity that can be exploited using IoT data analytics are aplenty. But the challenges that we talk about here, it is that, of course, the picture is bright, but it is not easy to realize to make these opportunities to happen. Therefore, there are multiple challenges in that arise from the IoT data analytics. For example, how to make machine communicate important data if they are belong to different manufacturer. The integrity of the data is obviously question too, and who will own this data and who will be or not be allowed to access this data. So the frequency of data sharing needs to be managed as data nature varies. So then there is a ever-present challenge of customer and device security comes in picture. So data science are bound to change, or the data analytics are bound to change the future, but not with the hurdles actually talking about. So these are the basic challenges coming to picture. So when you look into a smart sensor, basic thing what one has to understand is that there is a converter ML to digital, right? There is also interface on application algorithm. There is a memory which has to be temporary memory or maybe little bit permanent so that it can keep track of it. And there could be a communication unit or trans. This is the basic building block of any kind of sensors that we talk about. So when we talk about the sensors fulfilling the promise of the IoT, and it requires a different stages. So one side, the sensors and actuators, that is called the, so starting from a thing, things means anything, means any kind of, whether it's analog data or digital data or device from machines or people or tools, anything, and a thing is anything. And it has to collect it or go through a so-called sensors, maybe wire or wireless, and that requires a gateway, which is of data acquisition system, maybe aggregation, or maybe some sort of a control required, and it requires the so-called it is called ecosystem because it has to be evolved, it has to be processed, it has to be continuously going to give us the data or data collections, right? And the other side, two things were there, so-called for the advice or for the integrate or for the operation, and it requires a edge IT, which is nowadays coming up, so-called edge technology, talking about that apart from the cloud we talk about. And there is, of course, probably the data center or the cloud analytics we talk about that. This is the basic structure or infrastructure for any kind of IoT is talking about that. So when we talk about the human brain processing of sensory data and the IoT we talk about, there are two things comes in picture: human brain, which is cognitive important, and which is the place that hosts the cognitive intelligence, long latency, high computing power, big data database access memory, and this is nothing but simply a cloud or a host as of now we talk about. And there is something called a limbic component, which is immediate reaction, or could be a vigilance, or could be a locally contained behavior, and that is nothing but a sensors or in a bot we talk about. We talk about intelligent bot, also talk about that. So these two things comes in picture when comes as smart sensor or even if IoT device is concerned. Now, when we look for the IoT systems, when we talk about these things comes in picture, one is that you have a, yes, the data rate. We talk about edge computing, which is upcoming as of now. And there's a cloud storage, low power, ease of integration, right? And what has to handle with the latency, obviously. These are the drivers that driving the IoT system is concerned. When we talk about the dimensions, we talk about any time connection, any place connection, anything connection, we talk about that. So anything we talk about on the move or on outdoor, or even if any between the PCs or between the human to human or thing to thing, that we talk about nowadays any dimension as of now. When we talk about little bit what exactly the IoT, right? So let's watch a video over there wherein I'm going to show you that one, how seamlessly data has been collected, data has been integrated, data has been communicated, and of course communication is in the form of internet, right, in the form of a real time and in the form of a so-called the right the notification. Basically this is a futuristic video which is going to come, or many times this has been already taken into account. Let's watch this video over here. So this is life simplified. Two persons are coming to the home with a cycle, and the door is opening automatically. So in these cases, all these are in the form of a notification. Every time, everywhere, we got notification. Notification means obviously data has been processed and behind the scene and giving you the instant response. This is a futuristic video, but however, these are some of the places it is already implemented. And mainly it is trying to say that the connectivity in the form of notification, in the form of information exchange, in the form of information dissemination. So behind the scene, there are a lot of sensors involved, database, cloud, and processing capabilities involved. So there is a lot of fun in this. Now it got notification, and that the volume of the room has been given high, then so that he come out and doing all necessary tasks, including the information from the vehicle. Its status is showing to you instantly because it's again a time specific. All are connected. Including a toxic fumes which is taken care systematically. Even the fridge door which is not closed properly can give a notification, and then coming back and closing the fridge properly. So you see this is the information exchange in every piece of your life. It is recorded and processed and hence taken into account. Moving ahead, this is a long video, still I'm moving ahead. Okay, so smart systems, when we talk about, and IoT, when we talk about, is combination of basically three things: sensors, actuators, connectivity, people, and process. When you look for a sensors, you have n number of sensors we are have in the world with the digital nervous system, nowadays it is called, including location that using GPS sensors, including eye and ears using camera and microphones also, along with the sensory organs, and that can measure everything from a temperature to the pressure to the anything else. So these kind of sensors are nowadays available. Even if I will show you also that how the camera is a sensors, and looking into one of the projects which I worked, I will show you also later on that. So sensors like our actuators are like this way, starting from a small temperature sensor to the any kind of sensors over there. And there is a connectivity which is starting from a wire to the wireless, to the Wi-Fi, to the Bluetooth, any kind of connectivity we talk about, including local area network or a MAN or a WAN also that is the network is essential part of any kind of IoTs. And then most important thing is that the people and process, this is for whom and for what it has been used. So that requires your analytics, that requires your upgradation, that requires your remote monitoring, that requires your location tracking, that requires your supply chain management and security and many more things over there. That's the people and process. These network inputs can be combined into a bi-directional system that can integrate people, process, and system for better decision making. That's what the people and process. So the interaction between these entities are creating a new type of smart application and services nowadays. So when the compound application when we talk about, things get interesting when these connected devices and services start creating a compound application within their own verticals and across the industries. That's what the case. For example, this is a work which is of almost 4 years work and with a active daily living routines from monitoring and abnormalities of detection. This work is in the Adik University, Australia, and which is towards a healthcare and a smart home. And the article, the entire thing is published in the Springer Journal of Ambient Intelligence and Humanized Computing. You can refer this entire article, which is published in the September 2019. And there are multiple people involved in these cases. And I'm just showing you a few parts of it, not the entire project, right? So this is a smart home wherein we have used different kind of sensors, starting from a power meter to the camera to the tracking the entire living style of a person. Of course, we have used here person means one person, because keeping in target people living independently, a single person living independently in a home, and what is the active daily living. In fact, this is targeted to the senior people, or right, which is age of 60 plus or living alone, and that is what the system designed for it. And this is is a sponsored project. It's also from part of this government of Australia and Adik University, Australia. So this is a prototype model, what I'm trying to show you, and which is tracking a person, right, daily basis, 24/7, 365 days, and connected to the medical if anything required. And let's look at the simple diagram, what I'm trying to say: bedroom, living room, kitchen. And this is a prototype model, what I'm trying to say, wherein a keynet camera, which is a skeleton camera, of course, including the depth map also has been used. I'm just trying to say the monitoring include a passive infrared motion detector, magnetic field switch door sensor, pressure sensor of detect if a chair or bed is occupied, temperature sensor to detect if a stove is being used, water usage sensor, electricity consumption sensors to detect appliances uses, microphone array, smartphone equipped with accelerometer and gyroscope, and video depth camera that is talking about. This is a schematic diagram I'm trying to show, but actual diagram, some of the things I will show you, some of the things are copyrights, hence I won't show because there is also a business model behind this. When I talk about a simple camera, I'm talking about a keynet camera where is a sensors consisting of a depth sensor and a color camera, wherein infrared emitter, infrared sensors, and this is what has taken into a multi-dimension. And these are giving to a joint map, a skeletal representation is trying to show you. This is showing you a glimpse of a person sitting in the sofa, and its corresponding depth map of the scene, and the silhouette of the detection person has been also shown, because it requires a privacy also. So the actual person's things is showing in the form of a depth map like this way. So if you see different glance of this one, wherein we talk about the person starting from a dining room, sitting, standing, all things different places, and its corresponding images I'm talking about is given. All these are talking about a connected things, as I say that one, connected cameras, connected appliances, connected electronic appliances to measure the power meter. All this has been taken a prototype model over there. So if you see here something, I talk about a example of observation belonging to a longest identified frequent behavior of a person from a kitchen. You see this one kitchen, he is trying to do something. This side is trying to clean the utensil. All the actually its map has been taken trashed over there. So all these, I'm trying to say, these are a set of rules has been designed and defined, and with a little bit of AI involved in these cases, and these are giving us some kind of a graphs or some kind of triggers, and which will help to take a decision to for the other things to take care of this person's asset. So basically, ultimately, all these things are coming. Though some pictures I'm trying to show, but interesting things are my graphs, and the normal or abnormal, that things are numbers. Example, I'm trying to show you something like this. If you say here different a person different configuration I'm trying to show. So a binary image of the occupant of different frames I'm talking about, and his active daily livings has been closely monitored over there. At the same time, also I'm showing different pictures over there. So here, when I talk about the active daily living monitoring, so all this has been defined in terms of a rule, and that it shows me a different observation is trying to say that one. So now, if you see here in a kitchen, the abnormal behavior is that lying on the kitchen floor. If you see here, and this has been detected like this way, right? It's binary mask of occupant like this. Even if there's some this is treated as a sometimes can be treated as a fall, okay? Or here, if you see here, this is a small image wherein if I don't know if it's visible properly or not. This is a outside the kitchen. This there is some fall, and that is what is all detected, and is trying to showcase this one. And another picture where it is trying to say that there is a abnormal activities of sitting in an unusual location of the floor with a particular value. We're talking about the lower picture over there. So all this different movement has been tracked, and if anything abnormality with respect to rules, and that is a point of interest, and which is an alert or the notification which can be given to the outside world, and so that a proper care can be taken over there. So all this in these cases, when I talk about this one, though I'm not showing everything over here, so even if I'm not showing you the electrical appliances, I'm just showing you the different positions over there. But here also electrical appliances also comes in pictures. Example, suppose I try to say that one you have set with a mobile phone that one when you are getting off, and when you are having a coffee, because there's a coffee machine which is making a coffee for you, and which is set by your living style. Suppose if I get up at 5 o'clock or 6 o'clock and I'm drinking coffee at 6:30, then the coffee machine could be ready by 6:30 and coffee is ready for you. Whereas if I'm getting a late, how do the coffee machine knows? Yes, the coffee machine again a connected devices which is noting that one the person is getting late, or accordingly the coffee has been. So I'm talking about that one. Everything has been in the connected devices, which I'm not showing everything. I'm just trying to show that one a healthcare or a smart home point of view, where IoT as a device or IoT as a platform has been used to basically to alert automatically to a healthcare service, and maybe the authorized family members if any abnormal project which has been carried out in the Australia, and which is a sponsored project from the government of Australia for the largest, and that I'm showing a small prototype of it. The entire thing you can refer for the papers which I'm trying to show that one, detecting and deviation from activities of daily living routines using keynet depth maps and power consume data. This is in 2019 publication, and you can see from the Springer over there, entire things are there. So this is a glimpse. I'm just trying to show that on how the IoT or from a camera or a so-called a keynet camera point of view, and other appliances which is connected one, how it has been used in these cases. So intuitively, these integration becomes more as a tightly coupled across time, location, and service. Why I'm saying, because as location also very important, time is very important. The reason being, suppose a medical team has to come, and again it has to require location. Which location this happened? Obviously, then. So all this, when I talk about what I try to show here and connected to the multiple, or the multiple homes are connected to a network or towards say medical services, then obviously location, time, and all things there plays an important role while giving a notification. All things are there, right? Again, another one that I'm trying to show over here, the real-time service network. Again, this is a business model which I'm not going to reveal much over, but I'm just giving you trying to some idea over there. The name, all things has been changed for the IP conflict reason. So I'm just trying to say something like washing machine. When I talk about a industrial washing machine. Now I'm talking about the IoT has been used in the industrial washing machine to find out, not to find out, just to monitor closely 24/7, 365 days, because there is insurance involved there is a service sector involved, there is a manufacturing involved over there. So the point here is that one, a maintenance manager, a particular hotel's example, I'm talking just the names given over there, is stating that one something is failing, something is not working in washing machine. Means something means obviously a part must be malfunction over there. How you will come to know? So again, I'm talking about the sensors. The washing machine has been connected to the outside world, to the manufacturing sector, to the service sector, right? And wherein the insurance and you as a component, all these 5 components are connected over there. So when this going to the machine is likely to be going down, it has been also monitored over there. So the who are the service carriers, it is also monitored over there. Even though a notification comes over there, suppose when I say that one, that the washing machine needs a maintenance, so it gives you a maintenance information prior to that one. Again, the beauty here is that one, that a parts something is goes down, then the parts, again I'm talking about who are the order, the vendors who can look into the parts, and you have to click only the which one you want looking in done as per the your the price is considered over there. So again, it shows you the time taken to repair this, and online maintenance, which is trying to say that one, including a person delivering and repairing your machine, and all these are connected component over there. So here, starting from a intelligent application bids, and on the service request, on a receive notification, within this is having within a few minutes, and your washing machine can be repaired in just a couple of minutes over there. It even depend upon the kind of work actually. So here actually what I'm trying to say, the washing machine, I'm talking about a smart washing machine in the sense that one, it gives the information that when, or it is giving the information that one, when it is going to break down, and what are the parts are vulnerable, so that it can be replaced with respect to time. And of course location has been also as it is a connected device, hence location has been known, so that a proper place, a proper service can be taken out. So appliance monitoring, predictive maintenance, service technician, or even if a recycling also has been connected over there. So that is I'm trying to say, it's a connected device, right? Which is giving you a fully IoT based solution to. Of course, this is the mostly on the industrial application I'm talking about that one, but I'm talking about wherein the IoT has been involved. That means starting from a machine history to timing requirement to the pricing parameters to part specification to predictive sensors to a measurement and all these requests, all this has been come into in the form of in a notification, and including the parts and specification. All these are connected to service, insurance sector, individual, and manufacturer. Even if the manufacturer also want to know why this has been failed, which is supposed to be not failed actually. So even if the insurance sector also tried, is it worth, is it insured or not insured? So all these factors comes in picture. Hence, they're looking for a decision-making system. Then all these multiple parties coming together and through a online and able to make decision. You don't have to go to anywhere else. So it is happening through a network only. So that's what it's possible, obviously, with a IoT-based connected system, which is talking about this one. So when we talk about this IoT, then analytics or technology, then definitely one has to look into the kind of things required there. So vendor point of view. So if it's a data collection, then could be a data collection of maybe a RTOS or embedded system, or a ASCII or CSV file or JSON file. This is what we talk about that one. When comes a data transfer, we talk about different medium of data transfer, including the Bluetooth, Zigbee, or wireless RFID or whatever. Or in case of storage, we talk about Hadoop, HBase, Cassandra, MongoDB, Spark, or something. And the visualization, when I talk about, we talk about different kind of tools like a Tableau, SAS, RPKs, something. All these also involved when we talk about the analytics in the IoT, because IoTs are giving it only the information, only the sensors information, right? But again, this, if you give you want to analyze, if you want to visualize, then you require such kind of tools and technology along with the IoT also there. So that is what I'm talking about. The analytics technology vendor choice is always going with the IoT also. So when we talk about the business impact, the implication of these trends are enormous and vertically defined, obviously. And this is a standalone product also coming nowadays, and application markets will increasingly become a part of a larger network, which is a horizontal system basically. So the internet gave us the opportunity to connect the way we could never have dreamed possible. So that's where the IoT will take us a beyond connection to become a part of living beings and global nervous system that we talk about that. Whether you are individual or a technology developer or adopter of these technologies, the IoT will stretch the boundaries to today's system. And are you prepared for the changes in the way we are learning or hope or innovate? This is what the matter of concern as of now. You can imagine that if things start to think, though this is little humorous, but this is the going up talk now. It say that one too, a couple is trying to say that one, they are worried that we have to go out for a dinner, the refrigerator is not speaking to the stove. So this is what the kind of thinking comes in the mind as of now. So when we talk about the analytics, we cannot ignore that data on its own is useless unless until you can make the sense of it. So hence analytics is very much required. So in normal sense, that whether it's a predictive analytics, which is what should we do, or this is a descriptive analysis that what happened, or there's a predictive analytics which is talking about the predicting the future based what could happen. All these are again a part of any kind of analytics, whether it's IoT, all things are there which one should be aware of it. When you look into different kind of tools, that apart from this one, you should know also that some of the well-known tools starting from a TensorFlow to a Keras to a PyTorch to a Pandas, yeah, AWS, yeah, Google's Data Studio, all these kind of tools one has to learn or one has to use to find any kind of analytics of the IoT is talking about that one. So for example, when you look for a NumPy, this is a library for a Python programming language, adding support for a large or multi-dimensional array, and which is along with the large collection of high-level mathematical functions can operate in these arrays also. And when you look for a Panda, which is a software library written on the Python programming language for any kind of data manipulation and of course for analysis also there. eLearn or this launch skits, which is talking about is it is again a machine learning library that features different kind of classification, regression, clustering algorithms already there over there. And this is all based with both with a Python numerical or a scientific libraries, NumPy or SkyPy also there. This is that. So the Matplotlib libraries, which is giving you different kind of numerical expressions. The TensorFlow is again open source one, which can be used for a different kind of a machine learning applications of the neural network. Also, Keras can be used, which is open source one, and this is capable of running on top of a TensorFlow, right? And this also one of the first used tool also can which people are using this one. So apart from that one, there are notepad like a Jupyter, or you can use a CO or using a Cressel also. So all these, when I talk about tools, these are has to be carried along with the when we are talking about IoT analytics. Now let's look into another case study wherein we this is not my work. This is just I've taken from from a Chinese firm, and how this things is moving. Let's look into that one. This is what we talk about a upcoming supermarket, which is already established in the China actually. So looking into that, let me play over here. So this is Beijing in China. So this is a autonomous high-tech store, and which is by e-commerce against JD. To say this one, it is following you every step of the way, while it is automatically avoiding the obstacles also that, and it is scanning able to the QR code link card and put on the things in a proper way. Also calculate So all these things are very much futuristic, but which is also coming on the way. And what I mean to say over here, that is talking about a connected devices which is following you, because you as a person has been connected to this now the automated trolley. It's a smart trolley. It follows you, not only follows you but also calculate for you, but also able to help you to take a right decision to purchase a product or not to purchase a product which you want to do it. In fact, it is also telling you that when this product is came into store or has been put on the store, including other informations other if you requested. Even if sometime if you say that if you want to know where this product is so and so, the trolley will also follow a direction. The trolley will move ahead if you, and you may follow that trolley. So such kind of futuristic work is coming up here. This is based upon again the location-based service, and with obviously the connectivity and the GPS-enabled system, which is you and the trolley is now connecting over there. So this is just a futuristic one, but however, moving ahead, we will have a little differently one. The ability of sensors to understand the physics reveals some of the real-time context around a given person, which can then be combined with the expressiveness of the social media data to yield a strong understanding of an individual person or a group of people. But I'm trying to say that also that when we talk about a meeting means a virtual meeting. When we talk earlier, we have a physical meeting on the round table, right? Nowadays we talk about a virtual meeting is concerned. When we talk about a virtual meeting, obviously the intelligent chatbot has been used to record your communications. Not only your record, but also the everybody whoever is communicating or whoever has a discussion has been recorded. It is not only recording but also analyzing in a real-time mode. It is not only real-time mode, but also it looks into the profile of a person, and hence the business deal or the communication deal or communication, what it is moving or leading towards what direction, this is also trying to predict it. So in this case now, it happened that when you are expressing yourself in front of a camera, so we talk about a facial expression which is captured by a video, and there could be a accelerometer or a gyro motion or a audio cheering and booing also there, which is because it's calculate your happiness, all things are there. It also calculate the so-called heart rate, the skin conductance, which is the stress level also, and coupled with the machine learning based analytics to infer people's emotions in a way that was not possible before. What I mean to say is that there is a project which I have been involved, and wherein that one I'm trying to say that this is it's an advanced version of a chatbot wherein we talk about a social distance. At the same time, we talk about also that what is the business lead with respect to the profile of a person, whatever is a social media data, including LinkedIn, yeah, Instagram, whatever, and the information from you, not only you as a but group of people also, which all collectively behind the scene working and giving you a result. This is I talk about a project wherein it is giving you or trying to assist you the prediction of where the meeting is leading to. Basically, it is start with a minutes of meeting that we have been collecting. What happened that one, if there are so many meetings are there parallelly happening, and how the minutes of meeting be taken? Obviously, you as a single person, it is not possible for that one. And hence, the boards are involved now to have to organize or to carry out the parallel meetings and recording all such kind of things. Not only recording but also analyzing these things are there. So looking into all this one, there is another project where we talk about as I talk about the gyros or the motions or the cheering or the booing, right? Even if the excitement, all things are there. What are we talk about if we measure the through camera, that is called the heat map we talk about. Let's look into another one where I talk about this is a small playground where people are playing, and but however the audience are watching over there. And this is not just IoT only for the sensing, doing. We also talk about a sensor data wherein trying to understand people rather than things. So it is trying to understand the people. I'm just playing this video. Let's watch what happens over there. If you see, if you closely observe, there is a certain section of people wherein the color and the things are changing over there. And there is another section of people, the things are not moving over there. That means group of people are cheering, group of people are shouting, and their excitement levels are high compared to the other side over there. So it is real time monitor to understand the what is the excitement, what kind of excitement, when it's excitement, all things are there. So this will gives you a picture of that the excitement level, and hence the importance of the game that is happening over there, and how interesting that game is over there. So IoT is not just only or thinking something just a data analytic or the collecting business data, but no, there are something also going to the ground also there. Again, in this project also there, it's not only there are in the field also, each and every the individual players, the heat map or the so-called the skin conductance or the energy level has nowadays been monitored online, and hence it, because it is related to health, it is related to the excitement, it is related to the game. It is so they are, apart from though are they are physical fit or not fit, I'm not talking about, I'm talking about the energy level monitoring over there. So this is again a real-time monitoring happening in a, though it's an indoor game, but again with a multiple cameras, including the heat that we talk about now, as temperature measurement of a camera that we in the pandemic we talk about that one. So it is talking about the information collected and processing real time, and hence the excitement of mates has been collected, because there are different agencies wants to put the money behind the scene and to grab the business model. That's what another project I would talk about that one. Moving ahead to the a little bit more on the different section of side that we talk about a lecture attention analysis. Many of you are teachers. When you talk about the monitor or examine a student behavior in order to provide a approximate analytical inference, observed cognitive and behavioral pattern is a questionable about the time. Without asking, without knowing how the camera is going to monitor and attention analysis. That is what a small project we talk about, wherein we talk about this is actually a live monitoring happening over there. If you see it's a classroom happening there, some of the things people are reading, some of the things where you talk about someone just trying to sit over there, and just these two persons over there, yeah, they are chit chatting over there. Now when I talk about the objective, when I talk about this is a, we talk about a interpersonal interaction in a non-collaborative scenario, right? That we talk about. We talk about the how we can access such kind of things over there. So we talk about the drowsiness detection. We talk about the emotional recognition. We talk about that. We talk about the pose estimation, right? How they are posed over there, because this makes a difference over there. And we talk about this is just trying to say estimate a pose if you see over here from a classroom over there. And here also we try to say that one, this is your head motion, yeah, into an attention towards your body language. How? Because sometimes you use your heads to understand yes or no, yeah, whatever things, and your different positions are there. When we talk about what exactly the process, I'm trying to say, because every classroom has a cameras, even though could be ordinary camera, right? But still, this can be captured many of the objects, not necessarily entire classroom. I'm trying to a pilot study where we talk about one, but multiple persons' image can be also captured over there, right? So here, one wants to know, or the management, yeah, anybody wants to know what is the attention level of the students in a particular class when the classroom is going on. So this should be a continuous monitoring of multiple sessions has to be taken, even though it is maybe a different class, a different teachers and all things. So this can be processed, this can monitor, because the cameras are connected and cameras can be traced and can be taken care. So what happened? The video frames, when you talk about a region of interest, I can take a one, I can take a multiple also, right? And you can also detect a face, or you can detect a multiple face. Here you see the one, but multiple faces can be taken also there. So you can able to plot a graph. There is their emotions or their level of attention over there, and which can be calculated in a real-time mode, and which is the process. I'm just trying to show a glimpse of it, how this is making a observation over there. This you see there. The every movement has been observed, and this can be taken in real-time mode. Similarly, when I talk about here, even though this is not as a classroom, one left side is the classroom, but a right side, if I'm talking about, this is just a, like the remote classroom, and you talk about a student is trying, I'm just capturing his attention or whatever things level over there. So these are doable. These are as you are remotely connected, and this can be remotely also tracked, and which can be calculated, and which can be carried out, and gives you a different kind of pictures over there. I'm just trying to say that one, there are two persons over there. I'm just where there are two different multiple persons I'm talking about. As you say that one, your camera is facing and he's capturing your things, and this is talking about attention level over there. So when we talk about this, when we talk about these things are there, and here what I mean to say that one, the data we talk about is a data is collected from the ordinary camera that you or me are using, maybe of course a laptop camera I'm talking about. Even though for a laptop camera, whatever the resolution is with that, but you process through algorithm, and which is able to catch over there your informations, and you can analyze remotely and online, and you can say that one, and whether the attentive level of the students are proper or not proper. Right. Moving ahead with the another task that I'm trying to say, this is the work from the IoT in the little bit agriculture sector over there. When I'm trying to say, this is the IoT in agriculture, where in the Thailand I have worked in as a research mentor for agricultural products over there, and that is particularly I worked in the mushroom farming. Mushroom is one of the cash crop over the Thailand over there, and near towards the Cambodia region, some of the fields we have monitored over there remotely, and that I'm just to explain how things happen over there. When we talk about the IoT in agriculture, and in these cases we talk about this is basically for a government project over there, and wherein we are looking into the service platform, and looking into the different kind of services that can be given to the farming sectors over there, including irrigation, or including the storage capability, including the traceability of talking about, and a remote monitoring system we are trying to say over there. So here we different layers we talk about as a transport layer, and the perception layer, and the IoT application layer. The different layers we talk about that one. When we talk about the location, we talk about also the GIS, geographical information system, and IoT combined into. We look into the rainfall monitoring of different locations of the areas of our interest, which is talking about that we have combined this GIS and IoT over there, which is as a strong statistics analysis function, and has a good image demonstration function, and can be look into the a location-based service we talk about. This is I'm trying to show you some glimpse of over there, right? Wherein we talk about a real-time surveillance, we talk about a soil information analysis, we talk about alarm system, we talk about a remote device control, and policy support. We talk about that one. So here we talk. This is we talked all about, because all the things are distributed in nature. So hence this is a distributed computing application. Also one can talk about that one. So starting from a smart management to a fault analysis to a auto irrigation and to a water calculation, that was the work we talk about in application layer is concerned over there. And all these are also obviously to a mobile app based platform and a remote control platform. Both we have been talking about in these cases. So here, what is that one? We are providing a real-time acquiring data from farming and the IoT farming, which is towards the investment and insurance sector also. And also we talk about analysis and acquisible data, which make the valuable decisions we talk about. And this is also a government also look into the policy change, and this data also look for the government policy change also there. So we talk about the point to multiple nodes of wireless video monitoring system we talk about there. And we also talk about a heterogeneous network over there for a multiple modular fusion, including the ZigBee to a 4G to a wireless LAN to a GPRS to a Bluetooth. So multiple network has been used in the sense for a multiple regions, multiple fields, and with the suitability field, we talk about those things are there with respect to a given space and time. So we have major functions talking to is of real-time data, real-time surveillance, and the data storage we talk about, and analysis we talk about over there. So here, basically, the platform what we have developed is self-learning ability according to the any expert system we talk about, or this is also a intelligent control farm equipment we talk about this one. This is a project for the Thailand based one, whereas also a mobile app based project over there. Another project when I talk about is a GeoSense wherein I have involved. This is a Indo-Japan joint venture project which is for quite 3 to 4 years back. We talk about this one, and this is meant for the Geo ICT and sensor network based real-time decision support system for agriculture and environmental assessment is concerned. So in these cases, two agencies we talk about that one. What we talk about while I was working in the IIT Bombay, this project was carried out. This one. So this one is of something like this, whereas we have a different kind of systems over there. One is the Indo-Indian system and the Japanese system we talk about. So here the field server, when I talk about the equipment that you have seen over here, actually this is actually basically a server. That means it has a server capability. Even though it's a small, a very tiny device, if you talk about inside the pole, there are many more things over there. As schematically, I'm trying to show over there was a here in this case the fit to PC. What we talk about a small embedded PCs inside over there, and this also have a multiple sensors which is monitoring or collecting the environmental data over there in day and night over there, including a web camera which is of 180-degree rotations. I mean, rotation can be there, who can be zoom in and zoom out, and which is meant for surveillance, and not only surveillance but also for image processing for to find out the crop growth model as well as the pest and disease control we talk about. So these were the battery power devices in the ground. If you see here, all these are a rice field wherein the system is deployed over there, and this one is right looking in the a battery power and the solar power cell which is 24 hours is working, and this is what remotely we are monitoring from the lab itself, and then this was deployed over there. So the simple architecture what I try to is that one we have used a GPRS, Zigbee in this case also, and of course a 3G and 4G based system also used. And this is when I set upon it's all the data has coming to the GeoSense server where this was located in the IIT Bombay. And this is meant for live monitoring, crop modeling, pest management, precision irrigation, and decision support system we talk about. If you see here the figures I talk about, and we also talk about there is a ambient cloud that we have generated over, because cloud is a service we are providing in the field for data collection and the data monitoring over there. So this is from the field itself, we are able to provide a cloud-like service for a different the sensors, the different actuators we have been used. So in these cases, we have used the Zigbee XP as well as the field server talking about from Japanese point of view, and the Wi-Fi network, including the the ambient cloud. We talk about that. So here, when I talk about this, we talk about a distributed sensory system with IoT. When we talk about this one, if you see here this picture, there are the right hand side top corner picture. When I talk about, we have been, you see there's a tower over there. Tower is mean for, because this is a maize crop which is going to grow over there, which generally most go for up to the 7 to 8 foot level. So hence a different level of sensors has been put, because we are monitoring the growth of the plant. Monitoring growth of the plant, in a sense, we are monitoring the energy consumption by them, how much energy they consume while they are talking about. So this is again a 24/7, and for a one season when I talk about, season is meant for a 3 to 4 months, not entire year over year. So multiple season, whether it's a Rabi season, yeah, Kharif season, we talk about a multiple season with a multiple years we have been carried out this one to maintain our system as a robot system is concerned. So this has been seen from the one from Japanese people when they are sitting in Japan. They are observing this one from the field, and this is one side. We in India, when we are sitting, this location is mostly on the outskirts of Hyderabad, whereas we are monitoring from from sitting in the IIT Bombay laboratory over there. So all these are remote monitoring we talk about. Remote monitoring means physically we are not looking. It is the system itself is monitoring itself. I mean, one system is taking care of another system over there, and one system is also giving a trigger to another system to take care the whatever the right things or whatever right decision required over there. So this is what I'm trying to say. So we talk about a field Twitter. I mean, this also able to connect it to tweet, and because ultimately some informations we have to collect not only from the as a service as in on the mobile phone notification, but also can be connect to a Twitter, because we have tried to maintain can Twitter can be a server, can be a database repository that we talk about. Of course, you may say that on what information we are tweeting. Yes, tweeting the information in the form of these are the maybe a unprocessed one, because sometimes you may say that one, what is unprocessed? Unprocessed means that one the entire information is just giving a alphanumeric data, which is the person which involved knows, but other person may not. But this is again with if you decode it, then you will come to know what exactly. So in that way we are maintaining the security of the privacy of our data also, but this is we have also done over there. So when we look for the another system, the next version of that one, we call it a sensitive, from a geosense to sensitive, and this is also is a wireless sensing, and this is platform for the agriculture. And we have also a field-based station. This is a basically deployed in the Amravati district or the near Nagpur over there, and this is a government of India project over there and operated from the IIT Bombay over there. So if you see here, this is the actual picture of a orange tree, and beside that the device we are putting over there, and this is monitoring. This is what you see only one node. However, there are multiple nodes. As I said that from the picture, we are putting multiple nodes in the farm, orange farm is concerned, and these are continuously monitoring the data, and which is of importance, and that is giving you the information regarding what the tree is looking and what exactly is happening over there. So we look into the high scalability to deploy with a integration capability using a interoperable web-enabled sensing system. We talk about this one. This is what we did. Now, if you see here the system from a 2.5 meter to a 5 meter height, also we are analyzing to look into the from the top of a tree and what exactly it is happening with the tree. We talk about that. So the features of this one is mostly the temperature, humidity, soil temperature, soil moisture for the crop specific in situ agrometeorological monitoring is happening over there, and this is suitable for any remote deployment is concerned over there. And application areas are mostly for the crop water and nutrition management. We talk about that one, and this also we talk about a disease management. Also, we talk about a crop yield monitoring. We talk about that one. So this is a IoT based systems, and which is configurable for any configurable system. You can reconfigure also, because the time to time this has been taken out because of the season change. So hence it is more on the portable one. We talk about that. So one of the peculiar thing that we have done during that system is that one. This is where if you see here there is an insect over there. Its name is Jasit, and this is when it's the age is a little lower. When the it's adult, or it is not a if it is adult, then this color is changing. If you see here, I'm just pointing a cursor over there. The colors are changed over here. The same one which is looking green in color now becomes little yellowish, a little white words. So this shows the age of a particular particular insect. So this has been captured by our camera and try to monitor that one, how much damage they can cause, because those population can be calculated over there. So how this is well calculated? This can be calculated with image processing, like what we talk about the image. If you talk about, you can identify and identify different kind of insects, and because this is a sticky plate and the camera is monitoring over there, and this what is trying to counting, as well as the color change. All these have been monitored in a season wise, and this will come to not know that one with a square meter area, how many are there and how much they can cause a damage to a crop. This can be calculated, and which is used for the prediction purpose over there. So similarly, there is something like a small insect which is not visible to naked eye or camera cannot capture over there. So what we did in this case is that something like this, and there are other insects, big insects. If you see in the right hand side, the corner when I'm moving the cursor. So these insects are coming over there to eat out these small insects over there. So this is a veg pest. There is a non-veg insect over there. as you cannot calculate the small insects because which is not visible over there, so this one, the bigger one can be visible, and which is visible to camera, and camera can calculate this. So presence of these kind of the non-based insects indicate that one there is something wrong, and that's what they are present over here. So these are the farmer friendly actually over there, and this so counting these things means you are actually counting the which is actually damaging your crop. So again, with the image processing and with a real-time analysis, you can be calculated. As I said that one, the camera is there in the field round the time, hence all these are monitored over there. So it is not only the insects, but also any color change of your leaf, and its other capability also can be monitored over there. So here again I say that one, when I say that one, this is an IP based camera, and we can zoom in or zoom out as I talk about that one. So if any abnormal change happening over there, then we can make it zoom in or zoom out, and which is going to make things our easier for that one. So as I say that one, the camera is in the field, server is in the field, and we are simply with the internet, we are monitoring those things and trying to change any kind of abnormality. It is not only that one, the camera can zoom in, zoom out, not a physical way. If anything abnormality happened, the camera is programmed in such that one, it will be zoom in and zoom out that way it is. That is what the capability of a program that has been written, and which is making is a automated way, and it's of course a rule-based that is what I'm trying to say. Rule-based things has been used in these cases. So the system has been automated. Again, I am trying to say that one, this also we talk about a bit of the stress level of a plant. When a stress level of a plant means when you talk about a color and all things are there, and shape and size talk about, and and then the chlorophyll levels we talk about. So when a stress means a water stress, when talk about, when a camera observes all things, and the camera also triggers the water channel, and it gives you again the auto irrigation. And of course not in daytime, it again is a rule based one, it should be given in the night time, because otherwise evaporation will happen, and which will water loss is talk about that. So the decisions has been made, as I say that on the is a automated basis, means the what measure depend upon the water stress level, and the 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 system is now looking trigger, and there is a relay, and which is triggering the tap, and this is giving a auto irrigation over there. Now when I talk about the precision crop water and nutrition management, as I say that on the nutrition management and the crop, and talk about water. So this is a mathematical model behind this, which is working on it. It's not just a normal process, a normal sense, it won't work that way. So calculating and making all these, and we have been using or developed a mathematical model, and which is it is based upon the agricultural scientist, and no, we are not agricultural scientists, hence with help of agricultural scientists this has been developed, and the crop water requirement has been calculated. Even if the nutrition management, the nutrition level, there are different sensors nowadays available, and which is giving you the level of nutrition in the field. What I mean to say that one, that means the soil has a certain nutrition parameters are there. Certain soil has some deficiency over there. So if there is a deficiency for a particular crop requirement, then the nutrition, the artificial things can be given to the field, and when to given, how to given, where to given, that depends upon again the mathematical model and defined by the agricultural person to look into that one. So the crop water and the nutrition management, behind this there is a mathematical model running, and in the pipeline, when you talk about the flood irrigation, yeah, sprinkler irrigation, or even if the drip irrigation, all this nutrition can be given, so that the field condition can be improved over there. So that is what I talk about the crop water nutrition management. What talk about that one. Moving at this one, when I talk about the pest and disease, when I talk about, right, so you have seen there are pictures over there that here one insect is eating out, and there are some damage to the crop, and there is somewhere a person is spraying some sort of a pesticide over here. Again, all these, when we talk about that, these pesticide sprays, that one which is harming to the field, to the environment, to everybody, hence which is not a good practice, which is have been doing as of now. But how this cannot be be completely removed, but this can be reduced if we will take certain step, if we know certain things prior. So hence this can be, or if you know that one, how much is required and how much to be spread, and if we try to automate a system, then something can be saved over there. So that's another work that we have been talking about, the again a sensor based system. We talk about as of now, the farming community exactly unable to know the factors influencing the, I mean, I'm talking about quantifying the pest and disease dynamics at concern. So hence, through a sensors network or through a IoT, one can find out or know impact area wise also. I'm talking about this can be doable, can be carried out, which we have done it, and that one the factors that is influencing, and how can you know that this, you can know also with a prior in at least in 15 days advance what is going to happen, even though with respect to whatever the weather condition, yeah, climatic condition, but still there are models are there, and these models with respect to data collected from the field a real-time basis, and can show that one what is going to happen in the field in at least in 2 weeks in advance, so that some of the crops can be saved, and some of the the pesticide spray can be saved. All things are there, and this will reduce definitely the cost of the burden that is taken by the farmers over there. So what I told that with a the from the sensor data, and one can calculate and one can mention the correlation matrix, and what is influencing, what is not influencing can be. I'm just showing you a glimpse of a picture over which you may not understand all this data, but again you need a visualization to understand what this trying to say, because this is as a not a raw data. This also processed data, but the processed data may not be sufficient to give you insights about. For example, I'm trying to say a small thing over here. In this case, is example, when I try to say that when there is a something, then some red color I'm using, color code I'm using somewhere. For example, when I say that one there is a BNB, and there is a see, if you see here, there is a color I'm trying to show here, pointing a figure over there, a cursor moving. So there is a relation from a thrips to a BNB. BNB is a bird necrosis viruses, which is giving a correlation of 0.713. So that means what I try to say here. That means that one there is a that means there is a positive correlation of point in this scale 0 to 1, 0.713. There is a positive correlation. Is that means whenever this insect is there, there could be a disease of bird necrosis virus which is going to come. And the peculiarity of this virus is that one, if you are not taking care within 15 days, then it may kill the plant over there, which could be heavy loss over there. So such kind of the informations from the correlation matrix can be calculated, which can be portrayed. For example, I'm giving to a glimpse of it. In a particular figure. Look at the figure of the top right corner of this figure when I'm trying to say a bird necrosis virus, and I'm giving you different information. Example like a maximum temperature, minimum temperature, relative humidity 1 to in the morning and evening. I'm trying to say. So it is said that one, the relative humidity in the evening is playing a crucial factor. If the relative humidity is high in the afternoon section, then there is a significant threat coming to that particular crop I'm talking about. I'm talking about a peanut crop, a groundnut crop. I'm talking about this data I'm talking about. Similarly, there is a peculiarity that you see how this will come to know, because the sensors are giving data to you, and with the environmental parameters, and the camera is giving also information with the color scheme over there, and all these are correlating and trying to give you information that so there is something wrong and which we have to take care. That is the reason behind it, right? So if I say that the different colors has been used for different seasons, 1, 2, 3, 4, 4 different colors has been used over there. And even if you see this graph also, there's a peculiarity over here. For example, there are two things which is a downward. That means that they are negatively correlated. What it means, example, the second last one talking about AC. AC means age of crop. What is the age of crop? Age of crop means a crop may have a 3 to 4 months. I'm talking about the peanut crop is talking about mostly around 3 months as that one. If it is an infant, then this is the problem is there with virus. But if it is a not infant, it is adult crop, then definitely there is a negative correlation. The correlation is not going to happen when the crop is already grown up. Then this not happen. So these kind of peculiarity you can notice from a sensor data. When you process those sensor data, correlate with some other data, then you will get some critical insights of this one. So So as I said that one, sensors are giving a information, but again you require analytics to process those sensor data and give you. But however, as I said that one, some of the systems can be automated. For example, just I given to you that one, the irrigation can be automated. I don't have to see all such kind of thing. This system can take a decision also when to irrigate, when not to irrigate, obviously that one, right? Even though there is a stress, as I say that one, even though there is a stress in the daytime, but daytime cannot be irrigated. Reason being, daytime if I irrigate, then water loss is there also. Hence, definitely it should be after sunset. Irrigation should be there. So a rule-based system can be automated and make the agricultural system a better and better way that way. So like this way, there are particular insights we have observed over here, right? And not only this pest and disease, but also many more things we have done it also there. So moving ahead, so this can be, a simulation can be carried out, and what will happen and how things will move if something happens wrong. This one, even if you can at any moment of time, you can know that what is the infection level of a crop. Just a one single click, you can give information also there. So when we talk about the pest and disease and things, there is a new things that I just trying to say over there. See, when you go to the field, when I talk going back again to that field conditions, if you see here, a person is spraying a pesticide. When a person is spraying a pesticide, so it is spraying the entire field, yeah, whatever may be, right. So example, it has to go to the field, though there is something canal over there, is not flowing over there, but what about inside the field? If I go over there, you are having the pesticide spray with you also there. And is it required that you have to spray entire thing? The answer is no. The entire thing may not be sprayed also there. So you have to spray wherever it is required there. So what I mean to say, the new thing that we talk about nowadays, we talk about, can we use a drone to modify or to look into the where the spray is required, that one. So his drone is nowadays, even though any kind of drone, it's talking about a matter of 10 to 15 minutes of any similar drones of carrying capacity of, I'm talking about minutes because it has a battery which is of capable of these many minutes, because they are measured in it how many minutes it can travel over there. So this can carry a pesticide and spray wherever it is required, and you can monitor, or you can spray, or you can monitor all in a live over there. This is, I'm trying to show a glimpse over here. The question that one from it, if you see right hand side picture from a tractor, it is monitored that that spray is going to monitor over here. Now, it's when I talk about the drone, it's drone is not just I'm trying to say pesticide spray over there. No, the drone is making for a surveillance for it, because it is difficult to go into a field, because when you go to a field, you are damaging certain plants also. That if you take a picture from the top over there, it will be much more interesting than the going into field and seeing what things are there. Right. So many more things can be carried out with respect to drone is concerned. So the drone, when you talk about that one, we talk about a NDVI images. We talk about that one, right? When it collects a typical flights may take all the time 100+ images, and which can be software stitched together into a single high resolution image can be converted into this one. So it can be autopilot mode. It could be a software or post processing software can be carried out, or it could be a cloud processing can be carried out also over there. So the most common agriculture use for this one is for looking for a high visibility spectrum photos can be carried out here. So what I mean to say that one, so these things nowadays has been used for a nutrition, water stress, disease, and see, if I look for a camera or the different kind of pictures, if you look right side camera, it shows that the plants are somewhere stress, somewhere is a good, and somewhere not good, somewhere in medium groups are there. So this is a typical NDVI image, which is just show the change in the crop vigor sooner than the image over there. So by help of a drone and the IoT, I'm trying to say that one because you are in the field. Drone could be in the field, right? It is sending information, because when you look for a processing, the information is to process it not in the field itself. The information is processed somewhere else, and it is coming over there and giving a right decision, and it has to go or not to go. It has to spray or not to spray, what to collect, where to collect, and because it is a GPS based, it has to pinpoint location where it is going to happen. So looking with a GPS, looking with the IoT, looking with a drone, and all this has to come together and to provide a better picture for a scenario for the Indian agricultural systems concerned over there. So the system, when we talk about this, is more a very complex phenomenon, and the yield potential mostly depend upon a complex function where is the genetics, environment, farm practice, and other variability comes in picture. So if we're able to handle the equation properly, then the things will be carry a good. So ultimately, the data delivered through digital tools, which is basically we talk about optimized inputs and we talk about a maximized production, wherein the IoT can help in these matters over there. So when we talk about the agriculture sector for IoT, all these innovations for a live applications are going to be evolved based on the current technology. Maybe the cloud, maybe mobile, maybe remote sensing, maybe analytics, maybe IoT is going to ride of the convergence of the technologies and an interdisciplinary work that has to. Most of the the agribusiness will dictate the adaptation and leverage of this technology which is going to come up nowadays. So whether it's a weather resource or a labor productivity or any kind of a cultivation or a mechanized thing or any kind of a environmental impact or a policymaker, all these are now going to change with respect to IoT's concern. So IoT for agriculture will evolve in order to of the necessity for the farmers and the benefit it offers. And because in the developed countries like Japan and America and other countries wherein they have been put a lot of efforts on the IoT in agriculture, and that becomes a business model for them, and which is they are flourishing, and which is we have been India have been lagging behind in this area. To maintain a better productivity, and if we efficiently use these things are and government change the policy, government provide the subsidy to it, then definitely something can be carried out over there. So when we talk about the IoT or any IT infrastructure, so integrating a multitude of IoT device supporting the whole value chain can be look into a different technology or service provider, and which may move towards a data-driven farming, could be autonomous operation, and which could be virtualized for a food chains, and that may need for a reliable, secure IT systems as of now. So starting from a product to product system to the system to system, the IoT for agriculture needs to evolve to provide a comprehensive open architecture, and that is should be easy to deploy, and which may have a different perspective for applications, whether it's a ecosystem or whether it's a collaborative space or whether it's a open IT architecture. But IoT integrators or device are going to come and may help the Indian agriculture systems to carry out a better infrastructure and better technology provider, so that we can have a better system, and where is the food chain or the agriculture sectors can be carried out better way. So that is what the IoT, which may be important for the India and can also give a employment opportunities. Example, when I talk about even though devices are small device or whatever, but they are going to malfunction. Malfunction means who is going to repair? Obviously, it should be local level. When I talk about they can repair or such kind of things are there. So local level opportunity or local level employment or self-employment can come into picture over there. Whether it's a flying a drone or hiring a drone to look into surveillance, or whether it's a a repairing of any kind of a the in the small or portable weather system or any village level, all things are this is going to come in up in upcoming years, and wherein India is also moving to a so-called a digital agriculture and economy is coming back up over there. So wherein the IoT will play an important role in upcoming years, and where other countries are doing it. And this, though there are many pilot projects also government of India is doing, which I have shown you some of the projects also there. These are also on the way coming and to help the as a digital evolution of agriculture, where IoT will play an important role. And because IoT is a system, not as a system, but it requires also different kind of skills, and which will collectively provide a better system for that one. So this is what I would like to say over here. Thank you. Any questions? Let me know.
So thank you very much, sir. We have some couple of questions from the participants.
Yes.
Yeah, I'll read. The first question is from Vimal Bhatt. Question is how to apply NumPy Keras with IoT and how to use it. Any live example to implement?
See, IoT, as I said, that one, all these the data which I talk about, these are coming to via cloud, and these are supposed to be stored somewhere else, right? Whether you are data in motion or data in the cloud, all things. So ultimately, you are taking from a cloud actually. So whatever you want to apply, you apply at the cloud level. So hence your AWS cloud, the other cloud service has to be used so as to apply such kind of technology or tools and technology which can be process your information over there. So IoT device itself is not no processing power. IoT devices are mostly, though they are coming intelligently, but intelligently for the self-regulation, and that is for the self-healing or for a secure. But when comes to analytics, they are not capable of analytics. They are capable of obviously the outside and obviously the cloud and yeah, somewhere else. That is what. So any kind of a number, yeah, anything that you use, you have to use on the data which is stored or maybe in the cloud, yeah, on the notion when you talk about this can be captured about. That is what the answer.
Okay, thank you very much, sir. We have second question, which is again similar to this question. Where to store the large data set, as IoT devices have a very small memory. So answer is again you said now it's cloud.
Again, I'm saying that one. See, in our system, when I talk about, we were collecting data 24-hour basis, 24 hours 7 also. But partly the data were stored partly in the field. In the field, in the sense, those are again a temporarily before transmission actually, right? So of course they are also able to store those small devices. When I talk about a field server, they are maybe in, they are not in TB, they are in netmap GB actually, right? But however, those are for a temporary storage. Again, those data has pushed to the server, yeah, somewhere in, as I just shown you to the Twitter also. So data are always stored in the outside, not in the field level. Field level is there, but for a temporary point of view, right? And temporary point of view, what I'm trying to say, because there are certain times the system has to be doing himself or itself, and the system also has to be self-regulation also required. Hence, you require certain amount of data for the timing, and those amount of data for the maintenance of the system, that is only stored in the field. The rest actual other data are going to the out, and those are stored in outside actually. So the answer is that one, data stored outside.
Yeah, thank you, sir.
Yeah.
Again, one more question is there. Which techniques are used to increase data sets in case if we have very small data set?
See, small data sets, then you don't require these hi-fi technology I talk about. Small data sets, example talk about, so even I have shown you small systems over there where we talk about Indian systems are concerned over there. So data are mostly in the alphanumeric one, right? A simple RDBMS is also sufficient for this one. You don't require a hi-fi art because it's all data is simply alphanumeric. There is no image over there. There is no video over there. So if that is the case, then a simple RDBMS is also sufficient because of course, so data, as I said, data we are not stored. It is stored in outside. But again, the simple RDBMS is sufficient to analyze your data. Yes, you don't require for a small data set any high systems. Not required.
Okay, thank you, sir. Next question is from Simranjit. What are the security aspects of IoT?
Yeah. What is the?
I'll repeat
Please
the
repeat
question.
the question, please.
What are the security aspects in
Yeah,
IoT?
please. This is a gray area as of now, right? Is really it is a still is an infant, right? Security aspect is a gray area. Yes, systems are many cases not secure or may not be secure. But again, we talk about end-to-end encryption techniques. We talk, see, when you talk about a Zoom or talk about, it says that end-to-end. When you talk about WhatsApp message, take an encrypt. So such kind of techniques has been used for the data transmission. All things are there. But however, to a larger sense, yes, this research are still going on to look into that one. Secure area is a little still is a not as a grown up area, but only thing is that one end-to-end security, yeah, other normal security applications is a given. So example, when we talk about our own system, and I talk about that one. So when we talk about a transmission, we also try to ensure that one a different kind of algorithm. While we are, of course, encryption we have used and decryption we have used about. So while pushing the data we use, and also while downloading data we use the other one also. So such kind of the normal things we have been used particularly for information transmissions are concerned. But there is no other specific technology. Yeah, the people are working on as of now, but when comes to the security, yes, it is still to grow, and yes, this area of research still.
Thank you, sir.
Yeah.
We have last question from Sujata Oak, ma'am.
Okay.
What are the economic impacts of increased applications of IoT?
In India, when I talk about as of now, the electronics and all things are the market is still yet to grow. So yes, down the line, I will say not now, but 5 to 5 years, yeah, beyond the line, when this, as I said, that is the every IoT or small systems are inducted into our day-to-day life, and definitely there is a growing demand of things. When we are talking about a, even if the government of India also pushing also to out the make in India effort are concerned over there, and if it is geared up, definitely there is a large scope of the IoT culture is coming into India, and which will definitely a boom, not now but down the line 5 years it is yet to come, and it definitely is going to come, because it is coming in the, if you talk about the developed countries, and there is a, I have shown you a graph also, there is a significant change in the for investment, and people are investing money on that, because they want everything is to be automated way. Hence again in India also, this is also come as government of India has already taken up the policy towards a make in India, and definitely this is down the line, it is a growing economy actually here, right? So as of now it's not that much big, and we are procuring, but the moment when we talk about manufacturing and when we set up such kind of things, and definitely it is going to change the life or change the particularly electronic structure is concerned.
So thank you very much, sir. I request Vaibhav sir to proceed for the remaining part. Question answering session has been over.
Okay. Yeah, thank you.
Sir, please unmute your mic.
1 minute.
Thank you, sir.
Yeah.
Thank you, sir. Thank you, sir. Thank you very much. We are already late, but still we'll read, sir, two comments from the live chat box. One is from the Mohammad Nasiruddin. He's saying very informative session, sir. Kindly requested to please share the PPT. So he's requesting your PPT material, sir. And one comment is from Deepika Sharma. Such a rich session, sir, giving the real essence of IoT. Great broad view of IoT-based research going on across the globe. Enjoyed the learning. With this, thank you, sir. Thank you very much. And I request to all the participants, we are immediately moving to the next sections with the new link. So thank you. Thank you. We are ending the session here. Thank you, sir.